Dear students, warm welcome to online session. In this class, today's online session discuss about virtual clusters and resource management. The topics to be covered under virtual clusters and resource management are: what is physical cluster? What is a virtual cluster? What is the difference between these two? And another one is live virtual machine migration. How we can migrate from one virtual machine to another virtual machine live. Memory migration, file migration, and network migration topics also we will discuss. And finally, we will end the session with a dynamic deployment of virtual clusters. Let us move to the session, online session. What is cluster? What is cluster? Why clusters are really required for cloud computing? Cluster means a group of or a collection of computers or servers that are interconnected together through a network, but it can seems to be a single computer system, and it can enable the features of high availability, load balancing, and parallel processing is known as clusters. Consider here there are 1, 2, 3, 4, 5. 5 different computers which are interconnected together and combined into a single virtual machine. This is called as a clustering. This is called as a clustering. So the main properties or advantage of this cluster is the cluster seems to be a single device, not multiple devices. It can available, it can have some features like load balancing. It can share the load in a parallel and various cloud computing techniques. Now here we will compare the difference between two types of clusters. What is physical cluster and what is virtual cluster? Virtual is nothing but not actual. Physical is nothing but actual. Now we will see or observe the difference between virtual cluster and physical clusters in this slide. As we discussed already, clustering is nothing but it is a collection of or a group of computers or servers put together. A physical cluster is a collection of servers which are interconnected by a physical network such as local area network. That is known as a physical cluster. Physical cluster is nothing but actual cluster. That means that a collection of servers. Which type of servers? Physical machine servers. Which are this collection of servers which are interconnected together by a physical network. There are various networks are there which are interconnected to each other, such as a network named as a LAN, local area network. That is called as a physical cluster. Whereas virtual means not actual, not actual. We can create a new cluster that is called as a virtual cluster. That is not actual cluster. So in a virtual cluster, virtual machines are grouped and configured together in a network like a parallel computing to perform high performance computing is known as virtual cluster. So if you want to create a virtual cluster, what you require initially, we require virtual machines. How to create virtual machines? If you want to create a virtual machine, we need one software that is called hypervisor or VMM. VMM stands for virtual machine manager or virtual machine monitor or hypervisor. The main duty of the job of VMM or hypervisor is it is a software which can create or provide for creating an virtual environment, like we can create any number of virtual machines in that environment. So that means that virtual cluster is a machine which are grouped together and configured together for performing various high performance computing or parallel computing over a network is called as a virtual cluster. Here, one of the advantages is high performance computing. What is mean by high performance computing? If we are working with high performance computing, that means that our host system or guest system never failure. The system may not be failure in any point of view, so that will provide high performance computing. When a virtual clusters are created, after creation of virtual clusters, there are a collection of different cluster features that can be used, such as failover. One of the feature or one of the benefit of virtual cluster is failover. Second one is load balancing, and third one is live migration. So these three are well familiar features of virtual clusters. So the best feature of virtual cluster is failover. Failover is nothing but when we are working with virtual cluster environment, our systems, our client systems, our hardware systems may not be failure. The possibility of failure is zero. We can give assurance for that whenever we are working with any virtual cluster, the systems which are running on a network are not failure. Failure is over. Failure over. Next one is load balancing. Load balancing is a technique which can be used in virtual machines, which means that when we are using load balancing is nothing but whenever a server or a virtual machine is running with huge traffic, so at that time we need to divert the traffic received over to remaining available virtual clusters. So in this environment, so whatever available clusters, whatever available components or whatever available servers, they are equally sharing the memory or the load imported on that, which means that the traffic which is incurred in a particular virtual machine that can be diverted to another virtual machines which are physically available, equally sharing the resources. That is called load balancing. So load balancing is one of the another feature. By applying load balancing in virtual cluster, we can say that the system may not be crash. Why? Because the traffic is to be diverted to other virtual machines equally. Next one is live migrations. Migration is nothing but transferring the services from one provider to another service provider. Sometimes or many times we need to migrate our services from one service provider to another service provider. This can be done lively, that is called as a live migration. Why live migration is important here is, suppose consider an example of telecom broadband services. There are various telecom broadband services are available in the market, like Vodafone, like Airtel and BSNL. All these are service providers. The customer can migrate from one service to another telecom service whenever he required, wherever he required, simply by submitting a simple request to the service providers. That means that if a customer can compare the services of Airtel with the services of BSNL, if he is not satisfied with the services offered by the BSNL, he can able to migrate the services from BSNL to Airtel automatically by submitting a simple request. That is called as a live migration. So this live migration is also another feature. So this will be effectively utilized for virtual clusters. So that means that here we are comparing two different types of cluster. One is physical, another one is virtual. Physical cluster is nothing but actual cluster, whereas virtual cluster is nothing but not actual cluster. Something is created newly. That is called as a virtual cluster. Now here we can discuss a cloud platform with four virtual clusters, namely virtual cluster 1 in yellow color, virtual cluster 2 in light color, virtual cluster 3, virtual cluster 4. These are four different virtual clusters over three physical clusters: physical cluster 1, physical cluster 2, physical cluster 3, shaded differently. So that means that how the virtual clusters will differ with the physical clusters on a cloud platform. How it is vary, we will compare here. That means that compare virtual clusters with physical clusters over a cloud platform. How it may vary, we will discuss now. Let us consider a simple example here. There are three physical machines, namely physical cluster 1, physical cluster 2, physical cluster 3. These three are physical clusters. Physical clusters is nothing but a collection of computers which are interconnected together, but it seems to be a single computer. It is a physical cluster which is available physically. Here, virtual clusters is nothing but not actual clusters. So we can create something new. There are four different virtual clusters: virtual cluster 1, virtual cluster 2, virtual cluster 3, and virtual cluster 4. All these virtual clusters are maintained different types of individual computers which are interconnected together in a network. Here, if you consider virtual cluster 1, it consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 computers or servers which are interconnected together over a single network in virtual machine. The virtual cluster 2 running with three different group of cluster client machines or server machines. The virtual cluster number 3 having three having 6 machines, whereas virtual cluster 4 is running with 6 different server machines. So here the size of virtual clusters can grow or can shrink dynamically. This can happen based on the customer needs. So similarly, the overall network also varies in the size in terms of point to point network, that is called as a peer to peer network. So suppose in a virtual cluster, if you consider virtual cluster 1, there are 12 different computers are there. If any one of the cluster, if any one of the machine or server will failures, so the entire cluster may not be working. So the entire cluster may not fail you. The cluster will automatically run properly without any issue. Why? Because if one cluster or one software, one server failure, automatically the traffic over that one is to be diverted to another one. So automatically failure never occurs whenever we are working with virtual clusters. But if any failures are occur in a physical clusters or physical machines. The failure of any physical node may disable some of the virtual machines installed on the failure nodes, but the failure of virtual machine will not pull down the host system. Here, virtual machines can be replicated in multiple servers for the purpose of promoting distributed parallelism, fault tolerance, and recovery. So we cannot lose the data whenever we are working with the virtual cluster technology. Next, we can compare the physical and virtual machines with a simple diagram. Here, the concept of virtual clusters are based on with different applications which are partitioning over a single area over a SAM system area network. We will see here the network name is SAM. SAM stands for System Area Network. So it is a high performance network. It is a connection oriented only, not connectionless, that can link all the clusters which are interconnected together through a connection oriented only. So here there are various virtual machines which are placed over the hardware systems. So the virtual machine 1, virtual machine 2, virtual machine 3, virtual machine 4, different types of virtual machines are considered. So each and every virtual machine manager can maintain 3 or 4 different applications of virtual cluster nodes at the same time. So that means that here VMM stands for Virtual Machine Manager or Hypervisor. The main objective of this Virtual Machine Manager or Hypervisor is it can provide an environment for creating any number of virtual machines over the network with the help of the VMM. So here there are 3 or 4 different types of virtual nodes which are well connected to the virtual machine manager here. Here the first one is leading with 3 different virtual machines 1, 2, 3. So these virtual cluster nodes are A, B, C, and another one. This is running with 4 different virtual clusters, and this is running with 3, and this is running with 4. So all virtual machines are running with 3 or more different applications at the same time. So we can conclude that finally virtual clusters is a cluster which can constructed over the network. Next, fast deployment. For deploying a cloud, for deploying a cluster, we need to do in 3 ways: public mode, private mode, or hybrid mode. So here, the deployment. So if you want to deploy any cluster over the cloud computing, so it can have some features like load balancing and some of the deployment process, step process also we have been discussed here. First, what are the 4 steps for deploying a virtual machine on a target cluster? We will see here. The first one is before deploying a virtual machine on a target cluster, the first one is preparing the disk image. Preparing the disk image. Second one is configuring the virtual machine. Virtual machine is well configured with another virtual machine based on the needs. And choosing the destination nodes. There are various nodes which are interconnected together, and which node is well connected to another node. That mapping is also one of the features. Finally, executing the virtual machine deployment commands on every host. These are 4 different steps we have to follow whenever we want to deploy a virtual machine on a target cluster. So in this point of view, we have to we have to focus on load balancing. Load balancing is one of the feature of or the properties of virtual cluster, which can be achieved using a load index. and frequency of user logins. If the frequency of user logins exceeded the actual login capacity, automatically the traffic, huge traffic will be imposed on a virtual machine. So in this way, to control the failure of the virtual machine, we need to divert the traffic which is imposed on a particular virtual machine, that can be diverted or shared the traffic equally to remaining available virtual machines available on the network. So here the traffic will be shared equally, so remaining other virtual machines through the load balancing feature only. This can be automatically scale up or scale down the mechanism of virtual clusters that can be implemented based on this load balancing technique. Next, high performance virtual storage. So this is related to virtual cluster only. High performance virtual storage is nothing but some storage architecture designs can be applied to reduce duplicated blocks in a distributed file system of virtual clusters. High performance virtual storage. So how to improve the virtual storage performance? By removing the duplicated blocks which are already available in a distributed environment. If you are not reduced or removed the duplicate blocks, automatically the performance of your virtual storage will degrade. So that's why always we can always try to reduce or try to remove the duplicated blocks which are available in a distributed file system of virtual clusters. For that, removing the duplicate blocks, we can use the concept that is called as a hash map or hash value. Hash values are used to compare the content of data blocks, which are original one, which are duplicate one. So here, every virtual machine is configured with some features, some properties like the virtual machine is having a name and the virtual machine is having a predefined image, disk image. And each and every virtual machine is having a well-connected network secure settings and also CPU and memory. So every virtual machine is well configured with different properties like a name of the virtual machine, the image, actual image of the disk of the virtual machine. So what is the network setting it is, and what is the memory and CPU allocation for each and every virtual machine is not same for each and every virtual machine. If you compare these names, disk memory and the disk settings and the CPU's memories, all are not equal. They may vary from one virtual machine to another virtual machine. So the high performance virtual storage method is inefficient whenever we are managing a huge number or large number of virtual machines. Whenever we are working with a huge database, huge number of virtual machines with the same configuration, which may lead to simplify the process or predicating the profiles. Next, we move to live virtual machines. Migration. What is migration? Migration is nothing but transferring or moving services from one provider to another provider. So here live migration refers to the process of moving a running virtual machine or application different between different physical machines without disconnecting the client or application. That means that moving the virtual machine from one physical machine to another physical machine without any disconnecting network is called as a live migration. Why we go for applied live migration in virtual machines? In virtual clusters, we need to apply live migration for virtual clusters because of high performance only. So there are different types of virtual machines which are placed in a cluster. So if in a cluster, each and every virtual machine is having their own configuration, some virtual machines will perform well, some other virtual machines is not perform well. To overcome the problem, we need to migrate from one virtual machine to another virtual machine on live mode, that is called as a live migration. So each and every virtual machine here, we want to migrate in terms of memory, in terms of storage, in terms of networking connectivity of each and every machines are transferred from one guest machine to another guest machines. So the live migration of virtual machines allows the workload of one node to be transferred to another node very easily. However, it does not guarantee that virtual machines can randomly migrate among themselves. So this is one of the, there is no guarantee that virtual machines can randomly migrate among themselves. So live virtual machines allows us to perform some activities like automatically optimize virtual machines within resource pools. So resource pools means there is a collection of resources like memory resource, storage resource, and network resources. We can pick the optimized one, which one is optimized one, which one is very active, which one is very useful, which one is better one. We can pick one better thing from a pool, from a resource pool, that is called as the optimizer. So select always the optimal virtual machine from a resource pool automatically. That can be one of the best example for live migration. So the live migration performs hardware maintenance without scheduling the downtime or disruption of business operations. So what is live migration? We have been discussed in earlier slide also. Now, in live migration, if a virtual machine fails, whenever a virtual machine fails due to any reason, its role could not be replaced by another virtual machine on a different node as long as both run with the same guest operating system. But this can be done by this can be done by host OS, but this cannot be done by the guest OS. The virtual machines can be lively migrated from one physical machine to another physical machine. In case of failure, virtual machine can be replaced by another virtual machine here. So one of the drawback of live virtual machine is the virtual machine must stop playing its role if its residing host nodes fails. However, this problem can be mitigated with virtual live migration. This can be happen only when we are working, when two or more machines with working with the same guest operation system, but they are working with a different host operating system. This may not be happening. Next, here we can focus on in this slide how memory migration can be done, how file migration can be done, how network resource migration can be done. So we need to customer always looking for better resources. Always the customer looking for better memory, better file transfer, and better network resources only. So if there is no migration, we have to utilize the existing service providers what they're providing. But migrating means there are a pool, resource pool. From the resource pool always we have a privilegation for pick upping a optimized service from the pool. So which one is the, which we can always pick up the memory migration, which one is the best one, and the file migration, which one is optimization, and optimized network resources also we can pick from the resource pool. So memory migration means that can be in the range of megabytes to gigabytes. Here megabytes is very low capacity memory and gigabytes means very high capacity means. So the memory migrates can be a range of hundreds of megabytes to a few gigabytes in a typical system today, and it needs to be done in an efficient manner. Sometimes we need to move the memory migration from one system to another system, which is maintaining the data of memory with megabytes to gigabytes based on the customer requirement. There is a privilegation is there. Here we are using one technique that is called as a ISR technique, namely Internet Suspend Resume technique. Suspend means temporarily stop. A playing device temporarily stop means suspended. Suspend for some time, some interval of time. When we applied a technique resume, the suspended is to be converted into active mode. So it can be actually played. So that means that here one technique we are using the internet suspend and resume technique that can be used temporal locality as a memory states, like they are considered to overlap the suspended and resumed instances of your virtual machines. So that means that the device may be suspended and the device may be resumed automatically when in a virtual machines when we apply memory migration. Next we go for file system migration. Moving the file system from one service provider to another service provider automatically, that is called as a file service migration. So there are various file service management tools or clouds available in the market. One of the familiar one is Cloud Migrator. A cloud migrator can be used to migrate the file system files to Google Drive. Google Drive is one of the application to Microsoft OneDrive. This is also another drive maintained by the Microsoft or SharePoint. So using this cloud migrator tool, we can transfer or we can move the files from one system to another system in a Google Drive or in a Microsoft OneDrive or in a SharePoint of view. So the migrate data from one server to the destination server, this can be done by the help of the filters. The filters here we are using while migrating the files from one system to another system. If we are not applied filters, so there is a possibility of damaging the files. So here, whenever we are migrating the files from one system to another system, so some files are large sized files and some files are small sized files and some are the folders. So there is no restrictions over that. We can move the file system from one system to another system in a large size files or a folder files without any restrictions. So that means there is no instructions imposed on that one. Migration analysis to plan is an error-free migration. So these are file system migration concepts. Next, what is network migration? So moving the network service from one provider to another provider. Sometimes the customer need to move from one service provider to another network service provider automatically. Which one is performing very better? Which one is supporting for better network facilities to the customers? Always customers will look for optimized networks. So the network migration involves moving the data or programs from one network to another network as an upgrade or add on to the network system is known as network migration. Here the process of migration makes it possible to set up migrated files on a new network or blend two independent networks together. So that means that the files are migrated, the networks are migrated in a new network or two independent networks that is based on the requirement of the customer. Sometimes the network migration may result security issue. So why? Because here we need to stress one point that is called as a security issue. Why? Because whenever we are migrating from one network provider to another network provider, there are a lot of security issues. To overcome the security issues, we need to well analyze before migrating one network to another system network in terms of storage or in terms of restricted issues or in terms of independent networks together. So security is one of the main factor for considering while applying network migration for the virtual machine clusters. Here we can apply the technique of live migration to a virtual machine using Gen server. So here Gen server, so how Gen server will migrating from one source node to another target node. So that means that we are applying live migration technique for this source node to the target node, live migration of virtual machine from the domain 0 to XEN enabled target host. How it can be done, we will see in this diagram. Here, let us consider there are two nodes, namely source node, another one is target node. So the source node and target node, both nodes are running with hardware layer. On top of hardware layer, we can kept one virtual machine manager or hypervisor, which can be provide an environment for creating any virtual machines on the top of that. So the VMM will facilitate for creating virtual machines here. Here, this is the virtual machine, and this is also another virtual machine. We can create one virtual machine on top of that. So here the concept is we are migrating, we are moving the services from source node to another target node using live migration, using XEM server. We will see how it is. So the XEM server also supports a virtual migration by using a mechanism called RDMA, by using a mechanism called RDMA, stands for, which can be used for speed up the virtual machine migration by avoiding transmission control protocol or internet protocol stack processing overhead. So here there is a migration daemon thread. There is a migration daemon. This is a thread. The migration daemon thread running in the virtual machine. This is running in a virtual machine. So which are responsible for performing migrations. Here the shaded page table, this shaded page table in a virtual machine layer traces modifications to the memory page in migrated virtual machines during the pre-copy of the phases. So corresponding flags are set in a 30-bit map at the start of each pre-copy rounded. The bitmap is sent to the migrated demo. Then the bitmap is cleared and the shadow page tables are destroyed and the recreated in the next round. The system resides in XEN, that is the Gen management virtual machine over here. The virtual pages denoted by bitmaps are extracted and compressed before they are sent to the destination. The compressed data is then decomposed on the target node. So here we can easily move the daemon thread from one live virtual machine source node to the another virtual target node automatically using Gen server. Next, what is mean by dynamic deployment virtual cluster? Dynamic means not stable. It may vary while in terms of deployment, in terms of public, private, and hybrid of virtual clouds, how it is, we will consider here. Consider two types of clusters in this graph, namely physical cluster and another one is virtual cluster. A physical cluster is a group of clusters or group of computers which are interconnected together. They are running with a batch pool of clusters and a web service clusters which are well interconnected together. And here, this is a database. The database is called as a LDAP database, means that lightweight directory access protocol database. This is a set of open protocol database used to access. This can be used to access and modify centrally stored information over the network. So in this database, we used one protocol that is called DHCP. That means that dynamic host configuration protocol. So which can be used to provide automatic, quick, and central management of the distribution of IP address within the network, whereas DNS domain naming service is also another protocols, a set of protocols which can be easily controlled or managed by a database device. Here the database is having a two-way connection to the sharp, so virtual machine. It is maintaining a broker architecture and a service manager over here. So here the database is connected to the web service virtual clusters, which can be allocated raw materials, raw physical servers, or just virtual machines which are interconnected together. They can perform their activities through the network configuration resource management systems, and they can share the batch pool virtual clusters using dynamic virtual clusters whenever they require, wherever they want. So now we came to the end of the session. Thank you. Thank you so much.